Okay everybody, well today's the day. I'm going to replace the run capacitor on the carrier air conditioner for the second floor. I'm going to make this video kind of 50-50. What I mean by that is 50% casual video, 50% how-to video. I thought maybe I could have like a how-to video, but also be casual at the same time, you know what I'm saying? So I have the run capacitor right here. It's a, it's in the sun there, hang on. There we go. 45.5 microfarad. 370 or 440 volt AC, which is good, plus or minus 5%, and temperature range is all the same thing. So the most important thing here is you want to have the same microfarads and the same voltage range. So we are going to go ahead and get this procedure started. First thing I'm doing is I'm just going to go ahead and show what useful tools you can use for this job. Right here I have a 5/16 nut driver. The nut for the capacitor strap might be a different size. If it is or it isn't, I'll throw some text in the video right here. And then a screwdriver for possibly discharging the capacitor. I'll show you about that. And over here is a multimeter to measure some electricity. Alright, so first thing is first. You want to turn off your thermostats, obviously, but the other important thing is you don't want to have any power going to this unit whatsoever, because most air conditioners use 240 volts, and that kind of energy you do not want to mess with. So the one way that you can do that is either pull your disconnect in the panel right here, or if you have one of those square D panels, maybe I can show you a link or something as to what those look like. You may want to go ahead into your basement or wherever your circuit breaker is and turn those off, because those are known to fail in such a way where if you turn it off, it doesn't want to come back on. But in this case, this one is literally one that you pull. Now I already do have it in the off position, but I want to be totally sure there's no power going to it whatsoever. And there's not, but just to be a little bit safer, I'm going to pull it out completely and go ahead and leave it there on top. And obviously, to get to the parts that we need to, we just need to get this panel off here. Every unit's going to be different, but this particular one uses the 5/16 nuts, whereas the thing right there. Okay. Now on the top ones here, all you have to do is loosen them. You don't have to fully remove them. The top ones you can just loosen right here. That should be fine. And then this other one, which is right there, loosen that. Okay. Now there's two. Where is it? There we go. Two on the bottom here. These we will have to remove completely in order to get the access panel off. So even though we know that we've pulled the disconnect, it's a good idea to be totally sure that there's no electricity going to the unit with a multimeter. Now I'll show you how to do that. The way you want to do it is just follow the conduit that comes from the panel. Okay? And as you can see here, the wires come to this bottom portion of the contactor switch. So right there is where the power would normally be coming in from the panel. So the way to test it is, it's 240 volts, so you want to set your multimeter to alternating current, and the number above 240, in this case is 600. Okay, so now we're going to go ahead and take the leads of the multimeter. We're going to put it to the screws here of the contactor. One here, and one there. You can see they're both on there. And it's reading roughly just 1 volt. That could be from the meter itself. But basically, if you see anything like 120 or 240, that's not good. That means it's still getting power. So you got to find out where the power is coming from and turn it off. But in this case, with this just 1 volt right here, we're good. Electricity's off. We're okay to work on this. And this right here is the run capacitor for the unit. Now, normally run capacitors won't hold a charge when the unit's not running. But in case you want to be careful, you're a little concerned, I can show you a way to safely discharge it. Well, let me just go ahead and show you. There's the ratings. As you can see right there, they match what the old one, what the new one is. You may notice the plus or minus 6% instead of 5%, but that's totally fine. Nothing to be concerned about. And if you look carefully at this, you might be able to see a little bit of a dome effect on the top of the capacitor, and a little bit on the bottom too. I'll compare it to the newer one when I can, and then I can show you the comparisons between the two. One thing to note here is that it's probably a good idea to also take a picture with your phone or whatever, just to see which wires go where, to be totally sure that that you know exactly which wire goes to where, because that is very important. It may be kind of hard to see, but if you look on the capacitor here, let me see if I can show it to you. It's kind of hidden, but right there, okay, there's a thing that says C for common. Over here, let's see if I can show it. There it is. You see it says Herm. That's for hermetic compressor. That's where the compressor goes, and it's kind of hidden behind the brown wire, but that's for the condenser fan. So basically, the blue wires, the light blue wires for the compressor. The yellow one is the common wire, and the brown wire is the fan. It's also important to note that this unit has a couple of extra wires because there's a couple of hard start kits on here. Well, one for this one and one for the other one. That was done just because of the whole house generator that this house has, so that way you can give the compressors an extra boost when it's on generator power. So normally you'll just have 3 wires to your capacitor, but in my case there's more because of the hard start kit. If you have one as well, you should also take note of where the wires are installed. That way you know where to put them back when reinstallation happens. Okay, now if you want to discharge the capacitor, if you feel uncertain, what you want to do is you want to use an insulated screwdriver. By that I mean you have this handle here, which is obviously not touching any of the metal. You don't want to touch any metal with your hands while you're doing this. Then we have 3 terminals here. Okay, and what you want to do is you want to just put the screwdriver across the terminals, just to make sure it's fully discharged. It may be silently discharged. If it's not discharged, it may give a slight spark. But again, if it does, just make sure you're not touching any of the metal when you do this. Okay, put it across there, across there. All right, so any electricity that could possibly be inside the capacitor is now discharged. All right, now you can go ahead and start pulling the wires off. If you're going to pull the wires off, use your needle nose pliers. Now, I don't recommend pulling on the wire itself. Don't do that. Pull on the connector and just wiggle it until it comes off. There we go, just like that. On the top portion here might be a little bit better than the part that goes onto the capacitor terminal. All right, so go ahead and take the wires off, and then we can take the strap off for the capacitor. All right, as you can see, we got all the wires off. Now we're going to go ahead and use our 1/4-inch socket and go ahead and take the nut off that's holding the capacitor strap in place. Then once it gets loose, the capacitor may fall out, it may just become loose, but get this nut out, strap should loosen, you can get the capacitor out. And we're just going to compare the old capacitor to the new one. Just since it's easier to see, let me now give you a better shot, hopefully, of those letters on top. Yeah, see, there's the C for common, the Herm for compressor, and fan for the condenser fan. So this capacitor is very nice in the sense that it labels exactly where everything needs to go. Plus it's also a dual run, because that basically means, you know, it runs both the fan and the compressor. So there you go again. So once again, common, Herm, and fan. Now in this case I do want to point out 2 of the 3 terminals do match the wire color, but that won't always hold true, so don't rely on that too heavily. The best thing to do is to go based on what the letters, or what the letters, I guess, yes, say, or words on the bottom. Now, it's also good to note that this usually is pretty accurate, but if you look at the number of the terminals, common has the most, Herm has a little bit less, and fan has the least. So this is one way that you can tell them apart, for lack of a better term. And like I said before, we'll look at the bottom, or rather the top of this capacitor rather. See how it's nice and flat on top? Now, it's going to be hard to see, but look carefully at the old one. You can ever so slightly see a doming effect on the top of it there. And once a compressor domes like that, or bulges completely, it's done. So that's definitely a telltale sign that the capacitor has gone bad. Another way you can test a capacitor, if you don't have a capacitance test option like my meter doesn't have, unfortunately, you can use a resistance test around 20,000 or 200,000 ohms should work. And what you should see is you're going to put one terminal to the common and one to the fan and then one to the Herm for the compressor. So what you should see is you should see the ohms kind of start low, work their way up, and then go back to OL, which means open line. If you see them stay low, that means it's a short circuit. And if you see it say OL, or in some cases they may just say I for infinite, that means that it's bad to begin with. So I'm going to put one lead here to common, okay? I'm going to put one here to Herm. And if you look, OL, open line. Let's see, yep, there we go. Okay, now I'm also going to put the other lead to the fan terminal. And see, open line there as well. So there's another way to tell that this has gone bad. It's showing infinite resistance on both terminals with the common, so there's another sign that you need to replace it. And actually, one more quick test before I put this in. Let me show you one thing. I mentioned about it being flat, the new one. See how this doesn't do anything? Now look at the old one. See how it's wobbling? Because even the bottom has domed out a little bit. Yep. So there you go. That's a third way of showing how this has gone bad as well. All right, now let's go ahead and get the new one in. Okay, so one thing I like to do is, if possible, I like to put the capacitor back in the way it came out. And what I mean by that is, have the terminals be in the same position, or have the label face out. That way, if in the future it has to get replaced again, you can easily see what it is and get the replacement. Now I'm going to go ahead and fit it back into the strap here, just loosely for now. All right, just like that. Now, one thing to make note of is, obviously, you want the capacitor to be just below its lip, if you want to call it that, and have the strap that way, or any way up is okay, as long as it's secure and you can see the label for, again, a possible future replacement. And when you're putting the strap back on tightly, be absolutely sure you're not pinching any wires in the process. That way you won't have a damaged wire and possibly a short, which would be bad. So go ahead and get the capacitor back in and secure it with the strap with the 1/4-inch nut. Well, a little bit against my own advice, I wasn't able to make the label totally visible, but that's okay. I have a spare one inside, and I can always just write down on a piece of paper what the ratings are and the percentage. So again, in the future, if it needs replacement, I got it, so it should be all good. So as you can see here, all the wires are safely connected back to where they were. Now you can go ahead inside and turn on the thermostats. I'm going to do that before I go ahead and put the disconnect back in. Now, of course, if you can, if you want, put the disconnect back in before putting the panel back on, just to see if everything works correctly. But if you do that, do not put your hands anywhere near here, because it's going to be live electricity, 240 volts, don't want to mess with it. So let me go ahead and I will go get the thermostats on. Now, just to give you an idea of how warm it is up here, yep, 86 degrees Fahrenheit, definitely hot up here. So go ahead and turn this one on. Turns on right away. And we'll go ahead and turn the other one on because it's dual zone, and then we shall try the unit outside. And of course, before you turn it back on, make sure you have no tools remaining on it. Keep it all nice and clear. And if you look over here, the contactor has pulled in, which is good. All right, everything's all connected. We are ready to give it a try. So flip it over back to on. And here we go. Now, you may be hearing just a little bit of a vibration noise just because of the loose paneling. I don't have the screws back in yet, but that's okay. But I can tell you right now, you obviously didn't hear it the way I did before I took it out of service, but I can tell right now the compressor sounds a lot quieter, much quieter. And this fan is running much closer to the speed of this one now. So, like I said, those three things, or four things: more vibrations, louder compressor, slower fan, and hotter fan motor. And this thing is running just like it did before the capacitor went bad. That's fantastic. So that was the problem. Now this thing's running much better, much quieter, which is good. And again, much closer to this one now. And obviously the air coming out is very warm because, as you saw, it's 86 degrees up there right now. So this thing has quite the heat load on it, but it's running great, fantastic. Now, I am going to put the panel back on here with the power on. You can do that. Just be very careful if you do. If you're not comfortable with doing that, let the air conditioner run for, I'd say, at least 5 to 10 minutes, just because you don't want to short cycle a compressor. When you turn it on, let it run for a little while. Then if you feel uncomfortable about putting the panel back on with the power on, let it run for 5 to 10 minutes, turn it off, but also leave it off for another 5 to 10 minutes, because when you stop a compressor, you want the pressures inside to equalize, so there's not as much of a force or a load on it when you turn it back on. So just keep that in mind. Let me go ahead and get the panel back on for this. And that, my friends, is a job well done. Got the panel back on, disconnect's all closed up, 2 air conditioners running happily once again. And see, you save yourself a service call. You save yourself probably a couple to a few $100s, definitely. Sometimes if your air conditioner has a problem, it could be something as simple as this. Just this run capacitor caused those issues. I replaced it. This thing is running beautifully now. Fans, again, are much more equal speed. No two things are exactly alike, but they're much closer than they were last time. Compressor sounds much happier, even under the higher heat load right now from the upstairs. And it's been running for a while now, and the top of this middle of this grate just feels warm. Doesn't feel hot at all. Absolutely beautiful. And like, you know, that's the thing too, because if you can catch these things, you can stop something before it becomes a major problem. And I can't stress enough, guys, this is why it's good to know how to take care of your own stuff and how to maintain stuff. I myself simply came home from going out to dinner, and just by the sound this was making and what I could see the fan doing compared to that one, that tipped me off right away. I knew what the problem was, and the hotter motor temperature. But, so, let's see. So I bought two run capacitors, a spare one, for the downstairs one, should it need one. It cost, let's see, it was around in the high $70 range, okay? But two of those, expedited shipping, for just below $80, and you have a working air conditioner again, well worth it. Absolutely well worth it. So, once again, luckily it was something as simple as this. Fan motor was fine, compressor was fine, it was just this. And I know I'm kind of repeating myself here, but I just can't stress enough how proud I am of myself that I got this done, you know? So there you go. Now both floors of the house have air conditioning once again. Air conditioner is fixed, running much happier, got a new part in there, and a job well done. This is your reward. Couldn't be happier. Hope you guys enjoyed. If you guys need to replace a run capacitor on your air conditioner, hope this video helps. If it does, fantastic. Glad I could help you. Thank you very much for watching, and take care.